Yes, hello my dear students, welcome back to the channel. So in our previous video we have talked about the discovery of neutron and we have also talked about the discovery of positively charged particle, and later on Rutherford named that positively charged particle as proton. Okay, so but before going to the concept of the structure of atom, many scientists provided their own way or their own models for regarding the structure of atom. In that case, we have a very important model from J.J. Thomson, the discoverer of electron. He discovered electron and he gave his idea regarding the structure of atom. That is, the atom would be like this. The negatively charged particle will be staying here, and rest of the charges, rest of the spaces will be the positive charges. He gave this idea. So let us look in detail regarding this J.J. Thomson's atomic model, that we generally call it as plum pudding model, and also the watermelon model. We call this as also a watermelon model. Clear? So this is the structure how he demonstrated this J.J. Thomson's atomic model. That is also known as plum pudding model. It's just like a plum cake. Okay, so it's also known as watermelon model. If you just observe this, if you just take a round watermelon and if you cut it half, you'll get this shape. You need to assume that watermelon. Okay, you have to cut that into half shape and you'll get it. Okay, these are the red, that is fruit, and what you see in black, they are seeds. Okay, black seeds of the watermelon. So now let us see what he has said regarding this watermelon model. Okay, so this model was proposed in 1898 by the J.J. Thomson, the discoverer of electron, that is negatively charged particles. Okay, and atom has, according to this model, according to J.J. Thomson, an atom has a spherical shape. Okay, an atom is spherical shape generally, and the positively charged, what you are seeing in red, color, all these according to J.J. Thomson are positively charged particles, and what you are seeing in black, that is the negatively charged. In case of watermelon, what you see seeds are negatively charged particles, that is electrons. So according to him, this was the structure of atom. That is, the seeds, the electrons are embedded in like the black seeds in the watermelon, and rest of the what we are seeing in red color are rest except that seed particle, except that negatively charged particle electron. All other are positively charged particles itself, and that means according to him, the positive charge is uniformly distributed all over the atom. Generally, atom is spherical shape and the positively charged particles are uniformly distributed, and you have the negatively charged particles which are arranged in this pattern, in the same way of the pattern of black seeds which are arranged in a watermelon. This was his concept. Okay, electrons are embedded in such a way that the arrangement is electrostatically stable. That means you have these positively charged particles which are uniformly arranged all over the atom, which are in red. Okay, so we have said that an atom is a neutral particle. An atom is a neutral thing. That means if we have positively charged particles, we do have negatively charged particles. Okay, so then the negative charge and positive charge gets cancels each other, and atom will be a neutral thing. Clear? So in that case, in order to attain the electrostatic stability, how do you get the electrostatic stability? When equal number of positive and negative charges are there. Okay, they will get cancels each other and the stability will be upright. So according to him, you have the negatively charged electron like this, and the positively charged particles are arranged in uniformly throughout the atom, and thereby you get the electrostatic stability. Okay, so this model can be visualized as a watermelon. I have said you watermelon, what the sphere that we have, an atom is spherically shaped according to him, according to J.J. Thomson. So that let us consider as a watermelon of positive charge. All are positive charges itself, it is uniformly distributed, and the seeds, that is electron, that is black colored seeds, are embedded into it. Clear? And feature of this model is that the mass of the atom is assumed to be uniformly distributed over the entire atom. So according to this model, according to J.J. Thomson's atomic model, the positive charge is uniformly distributed throughout the atom. This was the concept given by J.J. Thomson, which was explained by this plum pudding model or watermelon model. Okay, so this is somehow somehow okay, but it was not purely accepted by the scientists or the people. Okay, so because of its limitations of J. Thomson's model, so it is no experimental evidence to any possibility. It just stated that the positive charges uniformly distributed. That's it. But there was no experimental evidence for his postulate. That was the first limitation. And arrangement of electrons are against Rutherford's model. So you will see the Rutherford's model. Okay, so arrangement of electrons in this case, J. Thomson's model, was against that of the Rutherford's model. We'll see that. Okay. And neutrality concept was not properly explained. We have said that atom is a neutral thing. That means the positive charge should equal to the negative charge. But in this case, the neutrality concept was not properly explained. It just said that we have negative charges here, we have the positive charges which is entirely uniformly distributed, and thus we get the electrostatic stability. But this was not properly explained by J. Thomson, and there was no idea regarding an empty space in an atom. Okay, he said that the complete atom is either consist of the negative charge particles, electrons, or of the positive charge. He said that there was no empty space, but later on we discovered that there are huge empty space in an atom, and there was no information regarding the idea of the empty spaces in that atom. So this is why the J. Thomson's atomic model failed. Students, we have discussed regarding the J. Thomson's atomic model. So the next atomic model is given by Ernst Rutherford, the founder of proton. Okay, so according to him, let us discuss what is regarding the model of Rutherford. Okay, so this is the concept given by the Rutherford. Let us see what it is. So Rutherford bombarded a very thin gold foil with alpha particles. See what you are seeing this. What you are seeing here. It is a very thin gold foil, a very small amount of gold. Okay, we took that very small amount of gold. Here we have just enlarged it. Okay, enlarged it in order to understand the purpose. Okay, so this is a gold foil. This is a very small amount of gold foil. What he did was he just bombarded the alpha particles. All these are alpha particles. All these are alpha particles, alpha rays. Okay, so it just bombarded this alpha particle to this very small amount of gold foil. Okay, so then this whole thing, that is this whole gold foil and the bombardment of alpha particle, was fully surrounded by the fluorescent screen. I have told you that what is the property of fluorescent screen. So it is that any rays that falls into fluorescent screen, that space of that fluorescent screen will glow. Okay, so we have the fluorescent screen all over here. If you pass the alpha particle from here and it reaches over here, okay, and if it touches the fluorescent screen, we have the fluorescent screen over here. Okay, this is the fluorescent screen. It is fully surrounded. Okay, when these rays touches this fluorescent screen, then this screen will glow. This screen will glow. Then only we can see that, we can feel that a ray is passing from here to here. Okay, that is the use of fluorescent screen. Okay, the next thing is the alpha particles taking the screen produce a flash of light. That is the use of fluorescent screen. This is a very simple experiment which is given by Rutherford. Okay, but its effect is very huge. Okay, it gave a good dimension, a good term for regarding the structure of atom. What he did was, he simply took a very small piece of very thin piece of gold foil. He just surrounded that gold foil by a fluorescent screen, and it just passed the alpha particle to that. It just bombarded the alpha particle to that gold foil. Okay, then the alpha particle, which is the least from one end to another end, when it reaches the fluorescent screen, the part of that fluorescent screen will glow. So this is the simple experiment. So now let us see what are the observations after this experiment. Let us look at the observations of this. Most of the alpha particles went undeflected. If it just passed 1,000 of alpha particles, around 990 alpha particles were get undeflected. That means they were not deflected, they traveled in a straight line. See, we have this much of alpha particles, so all this above and below are going undeflected. That was very unexpected observation. It's a very rare observation, okay? Because according to J.J. Thomson, we felt that there are no empty space in an atom. According to J.J. Thomson, all these are surrounded by positively charged particles. So if there is any positively charged particle, the ray should have deflected or it should have bounced back, right? But according to that was an unexpected result from Rutherford's model. So most, around 95-96% of the alpha particles went undeflected. There was no deflection, they traveled straight line. So that was the indication that all these are empty spaces. We will study regarding that in the postulates. Okay, that was the first observation. That is, most of the alpha particles went undeflected, and later on a very small fraction was deflected by small areas. Okay, around only 2 to 3% of alpha particles were deflected when it touches here, when it touches the edge. This is we will study regarding this. When it touches the only edge of this, that will get deflected. That is only very few percentage, that is around 2 to 3% of the alpha particles were dissected by only the small angle, and out of that, very few, only very few minute quantities of them bounce back. That means when the alpha particle hits this point, it gets bounced back nearly by 180 degrees Celsius, 180 degree angle. Okay, so with that was the observation made by Rutherford. That is, most of the particles were undeflected, they traveled in straight line. So the concept which was given by J.J. Thomson, that the positively charged particles, the positive charges uniformly distributed, something went wrong, because if there was any positive charges over here, it would have been deflected. Okay, and few of them were slightly deflected, and very few, very minute quantities have bounced back. Okay, this was the observation. So what we have concluded from this observation is most of the space in the atom is empty. So because of that reason only, most of the space is empty. Because of that reason only, most of the alpha particles went undeflected, because there was huge amount of empty spaces in them. Clear? This was the first observation. And the positively charged is not spread throughout the atom but concentrated in a very small volume. So according to J.J. Thomson, the positively charged particle, positively charged was uniformly distributed. No, but it was wrong. It has proved wrong, because most of the space is empty and the positively charged particle is concentrated in a very small. This is the positively charged. Okay, the positive charge of an atom. This is where the proton lies. It is very small and very hard, very dense. Okay, so it is concentrated in a very small volume. The volume of the nucleus, this is termed as nucleus. Okay, so this is nucleus, the very small and very dense part of an atom where whole the positive charge is concentrated, is termed as nucleus. Okay, the volume of nucleus is negligible when we compare the total volume of an atom. See, the volume of nucleus is very small. It is just like you feel the cricket ground where the wicket and crease are there. That is nucleus. That is very important. It is very small in volume. Okay, the whole ground is an atom, and there are huge amount of empty spaces. Just observe imagine the cricket ground. The wickets are just like the atom where the batsman leaves, and that is where the positive charges of an atom are there, and the whole ground is like an atom. There are huge amount of empty spaces between them, and the players around there are just like electrons. They will be revolving around the nucleus. Okay, they will be revolving around the nucleus, and we do have so much of empty spaces. Okay, that is his third conclusion. The volume of nucleus is negligibly small when we compare the total volume of the nucleus. Okay, this is regarding the Rutherford's atomic model. So now let us look at its postulates and limitations of Rutherford's model. Yes, students, now let us look at the postulates and limitations of Rutherford's atomic model. The first postulate of Rutherford's atomic model was the positive charge and most of the mass of the atom was concentrated in a small region, and he called it as nucleus. Okay, nucleus is the very small space, small volume of atom in which the positive charge and most of the mass of an atom is here. Okay, this space we call it as nucleus. Okay, and electrons revolve around the nucleus in circular paths called orbits. This was one of the good improvement by Rutherford's atomic model. He gave the concepts of orbits. Okay, before that J.J. Thomson, he was never talked about the concept of orbits. Okay, so here Rutherford gave the concept of orbits. He said that electrons will revolve around the nucleus in the circular paths called orbits, and electrons on the nucleus is positively charged. You know that because we have protons here. Okay, protons are positively charged. Okay, so and these positively charged protons and negatively charged electrons have the electrostatic force of attraction between them, because it is negatively charged, it is positively charged, so there is a force of attraction. Because of that reason, due to the electrostatic force of attraction, the atom is electrically neutral. Okay, and then the total negative charge is equal to the total positive charge which is present, so atom is electrically neutral. So these are the four important postulates given by Rutherford. And coming to its limitations, it failed to explain the stability of atom. Although explained regarding the electrostatic force of attraction and the number of total negative charge is equal to total positive charge, he was not clearly able to explain the stability of an atom. Okay, so that was his first limitation. And later on, distribution, he failed to explain even the distribution of electrons around the nucleus and their energy. So now we have shells, subshells, but during that Rutherford was not able to explain the distribution of electrons in shells and subshells. So that was the second limitation. And the presence of various spectral lines even in hydrogen spectrum. Regarding this, we'll study in the upcoming videos. That was just one more limitation of the Rutherford's atomic model. He was not able to explain the presence of various spectral lines. Okay? So this is very important postulate, limitations, observation, conclusion, and this diagram is very important from the point of a board examination. So pay attention carefully, and thank you, students.